This video is about simplifying radicals through multiplication. So one of the things that's really important is that we know these perfect square numbers that are going across the top here. These numbers, when square rooted, produce integers. An integer is a whole number, a number without a decimal or fraction. So what we're looking to do is to simplify or break up these into more simple radicals. So what I'm trying to do is I look at 50. When I square root 50, I do not get an integer. Okay, if I square root 50, it gets me 7.07. So what I need to do is I need to figure out which one of these numbers can I divide or can divide evenly into 50. So my strategy is I always cut the number in half, and then I start there. So half of 50 is 25. So I'm going to look at 25. Well, 50 divided by 25, that produces an integer, 2. So what I'm going to do is I'm going to break it up into the square root of 25 times the square root of 2. Now, the square root of 25 can reduce into just 5. And the square root of 2 cannot be reduced because it can only be divided by 1 as a perfect square. So we would just leave this to be simplified as 5 root 2, or you could say it also 5 radical 2. So here's another property. It's kind of the opposite, going from the second level to the first. I have two numbers here, and neither of them can be divided by the perfect squares. So what I'm going to do is I'm going to multiply 5 times 15. That gets me 75. So what I'm going to do is I'm going to change this to be the square root of 75. Now I'm going to see if 75 can be square rooted, or sorry, 75 can be divided by any of these numbers above to produce an integer. Well, I'm going to cut it in half. Half of 75 is about 37 and a half. So that means I'm going to start looking by doing 36. I'm going to do 75 divided by 36. No. 75 divided by 25. Yes, that creates an integer. So what I'm going to do is I'm going to split this into the square root of 25 times the square root of 3. Square root of 25, as we did the last time, breaks down to be just integer 5. And then the radical 3 cannot be simplified anymore as well. So this answer would be simplified to be 5 root 3. Now I have a different scenario. I have 2, but what I want to do first, remember, is check and see if they can be reduced. Well, 13 cannot. It's prime. So I'm just going to keep that square root of 13. 52, I'm going to start with about half of 52. Half of 52 is, I believe, 26. So I'm going to start with 25. So 52 divided by 25, no. 52 divided by 16, no. 52 divided by 9, no. 52 divided by 4, yes. So 4 and 13 is what I can break up 52 into being. So I can write that times square root of 4 times the square root of 13. Now the square root of 13 can't do anything, but the square root of 4 turns into just 2. So I'm going to keep this as square root of 13 and keep the other one as square root of 13. Now to simplify this, I can just multiply the two square roots of 13 together. I can do 13 times 13. That gets me 169. That number should start ringing a bell. So I still have my 2 out front times the square root of 169. The square root of 169 is 13. So now I can just write 2 times 13. And my final answer would just be whatever 2 times 13 is, which is 26. So review for simplifying radicals through multiplication properties. Use this to help guide you on our work this week.